So what I want to do now is work towards a general method. And so these examples here are just helping us come towards a general method. So if the left-hand side is a perfect square, i.e. a number that is squared, then we can find the solution by taking the square roots. You would agree with that, I hope. So for example here, if I have x squared is equal to 9, then we know that x is equal to plus or minus the square root of 9, which is plus or minus 3. That seems reasonable, yeah? All right. Now, likewise, this is a perfect square. It's x plus 2 is all squared. So if I were to do b here, I have x plus 2 all squared is equal to 16. So if I take the square root of both sides, that says x plus 2 is plus or minus the square root of 16, i.e. plus or minus 4. So that says x plus 2 is equal to 4, or x plus 2 is equal to minus 4. They are the possibilities. So that says that x is equal to 4 minus 2, or minus 4, or minus 6. So they are the two possible solutions to this equation. Let's go back and check. If I put 2 in here, 2 plus 2 is 4, 4 squared is 16. It works. Let's put minus 6 in. Minus 6 plus 2 is minus 4. Minus 4 squared is also 16. So both of those numbers work. So if the thing is a perfect square, I find the solution by taking the square root of both sides. That's the moral of the story. We'll do one more. Let's do C while we're at it. So C here is 3p minus 1 all squared is equal to 5. Therefore, 3p minus 1 is equal to plus or minus the square root of 5. Now, in this case, the square root of 5, it's a number, but its decimal expansion goes on forever. And so to write down the exact answer, I just leave it as the square root of 5. I can't simplify that any further. We know that from our surds. So I'm just going to leave that as plus root 5 and minus root 5. That's the number. So therefore, 3p is equal to 1 plus or minus the square root of 5. And finally, p will be 1 plus or minus the square root of 5 divided by 3. And there are my two solutions in there. Oh, this thing keeps coming undone. So my two solutions here are p is equal to 1 plus the square root of 5 on 3, or p is equal to 1 minus the square root of 5 on 3. They are the exact values sitting in here. So these are the exact solutions to it. If I were to approximate the square root of 5, this one turns out to be, I've got it written here, about 1 point, have I got a different colour? Haven't got a different colour, doesn't matter. This one turns out to be something like 1.079 to 3 decimal places. So that's approximately. This one turns out to be about minus 0.412 in there. So they're the approximate answers, but these are the exact answers. They're the numbers that make this equation true. So, if we can write the left-hand side as a perfect square, we can always find the value that works, is the moral of these examples here. And so, our method for solving quadratic equations comes down to the fact we can solve every quadratic equation, so we can solve every quadratic equation by this method that we're going to call completing the square. And what that means is we're going to write the left-hand side as a perfect square. And we do it by these little expressions that we had last week. This was called the square of a binomial. We had these last time, so we're going to make use of those. So let me show you how we do it. And I'll put these over here because we're going to need them. So these are the expressions that we've got to keep our eye on. So let me do one. So here we go. I want to try to solve this quadratic equation. X squared plus 6x is equal to minus 3. As before, I'm going to write it as quadratic trinomial equal to 0. So I'm going to have here x squared plus 6x plus 3 is equal to 0. Actually, I probably didn't need to do that. But anyway, the reason I've done it is because I wanted you to say, okay, if I want to factorise that, I'd go alpha plus beta has to be 6. Alpha times beta has to be 3. And I can't think of two numbers where that works. All right? So I'm in some sort of, hang on, yep, that's right. I can't factorise that. That looks too hard. So to me in here, I just left with question mark, question mark. So what I'm going to do instead of trying to factorise is I'm going to complete the square. And let me come down here. So that goes with that. Let me come down here. So I have x squared plus 6x, and on this side I'm going to have minus 3. And what I want you to do is I want you to look over here. I want the left-hand side to be a perfect square. I want it to be x plus a all squared. And if that's the case, I'm going to have x squared plus 2ax plus a squared. So for my left-hand side here to look like that, this 6 here has to be 2 times a. So here, 2 times a has to equal 6. So a has to be equal to 3. For those two terms to look like these two terms, I have to have a equal to 3. Now for this to be a perfect square, I have to add on 3 squared in here. So what I'm going to do is I'm going to add plus 3 squared. But excuse me, I just can't add that willy-nilly. So if I add 3 squared to that side, I've also got to add 3 squared to that side. So what I have done here is I have completed the square. What I've done is I've added in the correct term to make this a perfect square. And because I added it on that side, I had to add it in on the right-hand side as well. So, because I've added in a squared, this left-hand side must be x plus 3 all squared. That's why I added in the 9. So this is in fact x plus 3 all squared is equal to minus 3 plus 9 is equal to 6. Just check it out. If I were to multiply that out, let me just do it. X plus 3 times x plus 3, that is x squared plus 3x plus 3x plus 3 squared. You can see it. It's x squared plus 6x plus 9. There it is. All right, so I did add in the right number in there. And now that I've got it like that, I can just go back and do exactly what I did back here in these examples. Right? It's going to be like this, well, going to be like this one. Right? I can now do it. So I now do as my previous example says. So therefore, x plus 3 is equal to plus or minus the square root of 6. Take the square root of both sides. So x is equal to minus 3 plus or minus the square root of 6. They are my solutions. Interestingly, if you're the inquisitive type, you could go back and actually have a look and see if these numbers here would have satisfied these equations up here. Alpha times beta equal 3 and alpha plus beta equal to 6. And you will find that minus, well, it should be minus 3 plus root 6, and minus 3 minus root 6 will actually work in there. They are the numbers that when you multiply them, they go 3. When you add them, they add to 6. You wouldn't have guessed those, I don't think. Okay? So we had to complete the square in here. But anyway, I'll leave that just as a challenge for those who are interested. All right. Let's do B. So B says x squared minus 8x minus 4 is equal to 0. Once again, if I try to factorise that, I come unstuck. I can't guess the numbers that work. So I can't factorise it, so I'm going to complete the square instead. So in here, I have x squared minus 8x, and on this side I'm going to put the 4 over there. According to my rule over here, x minus a all squared, x squared minus 2a, so I have to add in a half of this coefficient all squared. That coefficient is 2a, this is a squared. So I'm going to halve that coefficient and add in the square of it. So this is going to be plus 8 on 2 all squared. And since I added that in on that side, I have to also add it in on that side. Eight on 2, of course, is 4. And so on this side, let me write down, I have x squared minus 8x plus 16. And here I've got 4 plus 16. And if I've done my addition, added in the correct term here, this should be a perfect square. And it should be x plus 4 all squared. X minus 4 all squared, I should say. And on this side I get 20. Just check that out, x minus 4 all squared. You can check that to make sure you got it right. X minus 4 times x minus 4 will give that. So you can check that you've got that step right. And so now I can say x minus 4 is equal to plus or minus the square root of 20. Add 4 to both sides. So x will be 4 plus or minus, now the square root of 20, in fact, is the square root of 4 times 5. So that's in fact 2 root 5 in there, I could write that as. And so there are my two answers, 4 plus 2 root 5 and 4 minus 2 root 5. And so once again, these are the exact solutions. So this method works even in the case where you can factorise these things. So if you're terrible at factorisation, you might say, well, I can use this method instead. Factorising, of course, however, is 15 times quicker. Okay? But if you can't, I guess it's only quicker if you can do the factorisations. If you can't do them, then it's not quicker, I guess. Okay? But this method always works, never fails. Unless you make a mistake, but that's not the method's fault. Okay? This is a very robust method. So, sit there. So if I were quite clever, and I think it's in your notes if you have a look, if I start with this quadratic trinomial, the very general one, ax squared plus bx plus c, and I complete the square on it, and then solve the resulting equation, I end up with these as being my values for x. And so the quadratic formula, in fact, comes from completing the square. So this is the formula that you get when you complete the square. Notice that in here you have to take the square root of b squared minus 4ac. So if that's positive, I'm going to have two answers. If it's equal to 0, I'm only going to get one answer because the square root of 0 is 0. And if it's negative, then that tells me there are no values of x that solve the quadratic equation. So far we haven't seen any of those, but I'm sure one of these down here will be one of those examples. So this thing comes from completing the square. Comes from completing the square. And as I say, so given a quadratic equation, you can always find the answer via the quadratic formula, in fact. So let's do some. So this one says, solve a 3x squared minus 9x plus 4 is equal to 0. So in here, remember, this formula applies to, and I probably should have highlighted it, that equation there. So A is 3. B, in this case, is minus 9, and C is 4. AX squared plus BX plus C. Having identified the values for A, B and C, I then just substitute them into this formula here. So it says the solutions to my equations will be x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So by substituting in the formula, I have my solutions. So I have here minus 9 is plus 9, plus or minus the square root of. Minus 9 squared is 81. 4 times 4 is 16. 3 16s are 48. All on 6. 81 minus 48 would be 33. So here I have 9 plus or minus the square root of 33, all on 6. Excuse me, I don't think I can simplify that any further, so they are my solutions. 9 plus the square root of 33 on 6, and 9 minus the square root of 33 on 6. Those numbers are fairly hard to check. Conceivably you could do it, okay, but that's harder than solving it. Let me now have a go at B. I would say this would be a really good formula that you would have on your cheat sheet, wouldn't it be? Wink, wink, nudge, nudge. Okay? There we go. So let's do B. B says 2x squared equal to minus 4x minus 2. So let's make it quadratic trinomial. So here I've got 2x squared plus 4x plus 2 is equal to 0. Now, I could work with it there and say A is equal to 2, B is equal to 4 and C is equal to 2. But I think it makes sense to divide by 2 first, I'd reckon. So I would write that as x squared plus 2x plus 1 is equal to 0. Because 0 divided by 2 is 0. So I've divided both sides by 2. Now, let me just say here, I recognise that straight away as x plus 1 all squared. And so this has just one solution, x plus 1 is equal to 0, so x is equal to minus 1. Right? In this case, it was easy to factorise. But let me use the formula anyway, just to see if it comes out to give the same answer. First of all, let's just check it. Minus 1 squared is 1, so I've got 2 on the left-hand side. On the right-hand side here, I've got minus 4 times minus 1, that's 4. 4 minus 2 is 2. So I've got 2 on both sides. So minus 1 does work. That is the solution. So in this case, it was easy by factorising. But, as I said before, the other one should work. So let's do it. So in here, if I'm going to use my formula, A would be 1, B would be 2, and C is 1. A is 1, B is 2, C is 1. Substitute into the formula and you get x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all on 2 times 1. And so here I have minus 2 plus or minus the square root of 4, minus 4 on 2. Notice 4 minus 4 is 0, the square root of 0 is 0, and so this just becomes minus 2 on 2. And so I have just one solution, minus 1. And so my quadratic formula gives me the correct answer as well. And what we had here was an example of when b squared minus 4ac is equal to 0, there is just one solution. Because I'm adding 0 and I'm subtracting 0, so I only have the one answer. That's not two answers anymore when that's a 0 sitting there. Okay, so I get just one solution to my quadratic equation. And C, I've got, where's C? It's over there. I might get another page and do C. So I've got to do C here. This will do. So now I'm doing 2x squared. So here's part C. It says 2x squared plus 4x plus 3 is equal to 0. And that would drive me batty there. Let me straighten that up. So in this case, the coefficient of x is 2, x squared, the coefficient of x is 4, and the constant term is 3. So I have A, B and C. And then I substitute into my formula, and I get x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all on 2 times a. This becomes minus 4 plus or minus the square root of 16 minus 8 threes are 24, all on 4. Now what happens here, I've got 16 minus 24, that's minus 8. I can't take the square root of my negative answers in this case, so I'll say since b squared minus 4ac is negative, that tells me that there is no solution whatsoever. So no matter how hard you try, you can't find any real number that when you substitute into here, I get 0. No number works. No solutions, in fact. Okay, and so what's likely to happen in an exam or a test is that you're just given the quadratic and you're free to solve it by whatever method you feel fit. Okay, so you might want to use the quadratic formula, you might try to factorise, whatever. So let's have a go here. So part A says I want to solve 2x squared minus 5x plus 2 is equal to 0. Now, I mean, you could go straight in and do the quadratic formula, and that would be fine. But I would always try to have a go at factorising first. So in this case, I would say, look, alpha plus beta has to be minus 5. Alpha times beta has to be 2 times 2, has to be 4. The fact that alpha times beta is positive says alpha and beta are the same sign. Because this is alpha plus beta is negative, they're both going to be negative. And so to me, I think that seems pretty clear that alpha equal to minus 4 and beta equal to minus 1 is going to work. They multiply to 4, add to minus 5. And so my factorisation is 2x minus 4, 2x minus 1, all divided by 2 is equal to 0. And so I have 2x minus 4 is equal to 0, 2x minus 1 is equal to 0. So x is equal to 2, or x is equal to a half. That's how I would do it. You could complete the square if you wanted to, but you're probably better off just going straight along and using the quadratic formula if you didn't want to factorise. So I could say, or, let's do it this way. Let's go. A is equal to 2, B is equal to minus 5, C is equal to 2. And therefore, by the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all on 2 times a. Negative 5 is plus 5. Here I have the square root of 25 minus 16, all on 4. 25 minus 16 is 9. The square root of 9 is 3. And so my two solutions are x is equal to 5 plus 3 on 4, which is 2, or x is equal to 5 minus 3 on 4, which is 2 on 4, which is a half. Same answers, which is good. We want both methods to give the same answer. Yep.
Would it be, like, in a test, would it be acceptable just to leave it as 5 plus or minus 3 and 4, or would you prefer?
Well, in a test, you're going to have multiple choice. So you're going to have to simplify it. Yeah. Yeah. Okay. But Jiminy Crickets, I think you could probably simplify that, couldn't you? Yeah.
I'll just ask.
You would put me in a quandary. Because I would say, you can do that, come on. You kidding me, you're going to leave it like that? Yeah. I mean, the instructions do say simplify as far as possible. So, strictly speaking, I could ping you. Depends if I'm in a good mood or not. Or there's money attached or something, you know. I didn't say that, Echo, I didn't say that. Okay. All right, let's do this one. Let's do this one. Find a bit of paper. Here's a bit. Okay. So, part B, what I would do is I would rewrite that as x squared minus 8x plus 13 is equal to 0. So I want two numbers that, when I multiply together, give 13. Now, 13 is prime, so it's only got two factors, whole numbers, 13 and 1, and they certainly don't add to minus 8 no matter how I try. So I can see straight away factorisation isn't going to be helpful here. So I'm going to launch straight away into the quadratic formula. So here, A is equal to 1, B is equal to minus 8, C is equal to 13. And so I have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all on 2 times a. This is 8 plus or minus the square root of 64, 4 13s, 40, 52, all on 2. This gives me 8 plus or minus the square root of 12 on 2. And there are my solutions. In this case, and I definitely wouldn't ping you for this, but this can be simplified a little bit more, in that the square root of 12 we know is the square root of 4 times 3, and so that's 2 root 3. So I can write this as, so I'll put in here, this is equal to 8 plus or minus 2 root 3 on 2. Then I can say, look, that's 2 lots of 4 plus or minus 4 on root 3 on 2. So 4 plus or minus root 3. So 8 plus or minus root 12 on 2 is the same as 4 plus or minus root 3. And I think that is simpler. But as I say, if you can get down to there, then I would be more than happy. I would feel you've done well. There could, of course, be a third question that asks you to simplify that. Then you'd have to do it. Yeah. Okay, I think we've solved enough equations for one day.